Hey guys, welcome back to the channel. Throughout this playlist, we have seen that there is no single prompting technique that works best for every problem. Different techniques solve different challenges, whether it's improving reasoning, exploring multiple solutions, or interacting with external information. However, the prompt engineering literature contains several other interesting techniques that, while not be as commonly discussed as chain of thought or React, are still significantly important to improve the performance of language models in specific situations. So, in this video, we will be taking a look at three such techniques: generated knowledge prompting, least to most prompting, and reflection. Let's start with generated knowledge prompting. The idea behind this technique is very simple. Instead of directly answering a question, we first ask the model to generate or recall relevant background knowledge related to the topic. This is done via the help of few short prompting. This generated knowledge is then fed back into the prompt and used to improve the final reasoning process. In simple words, instead of directly answering the question, the model first gathers information that may help it answer the question more accurately. As you can see in this example, when we ask the question if in golf players try to get the highest score possible, so the model might get confused. So it first generates relevant knowledge related to the field, which in this case is golf. Then, with the help of this generated knowledge and the input statement, the model finally gives a response, which is generally better when we use the knowledge based prompting. So, here are a few advantages and disadvantages of generated knowledge prompting. So, firstly, it helps a lot in improving accuracy as we have the significant background knowledge to help the model answer correctly. And secondly, it also reduces hallucinations a lot as rather than making unsupported assumptions, it has the relevant knowledge to answer the question. But it also has certain limitations. Firstly, the quality of the response depends a lot on the knowledge that is extracted from the language model first. The knowledge can be incorrect or misleading, which can lead to the final answer being wrong. And secondly, if the model gives some irrelevant information in the knowledge base, then the language model, while generating the final answer, may get confused on what it actually needs to answer. The second technique is least to most prompting. The core idea is to first break a difficult problem into smaller and easier subproblems and then solve those subproblems one by one. The model is trained for this process via few short examples. That is, instead of directly attacking the entire problem, the model gradually builds the solution from simpler components. This makes the technique particularly useful for tasks involving multi-step reasoning. So as you can see in this example, we first have a question which we break it down into simpler, smaller subsequences, and then each question is tackled at once. So we break the first question down into subsequences, and the first sub question is answered. Then the response we get, we input it into the second sub question, and finally, via this process, we get the final output. So people generally get confused between chain of thought and least to most prompting. So in chain of thought, the entire process is a single iteration. We get the problem, we think of the solution step by step, and then finally get the answer. On the other case, in least to most prompting, we break down the problem into smaller subproblems and then tackle each of those individually. Here are a few pros and cons of least to most prompting. So, firstly, it is very good for complex tasks and it breaks it into simpler sub questions. It's easier to solve them. And secondly, the reasoning is step by step, which helps in improving the understanding and also helps the model stay organized. But it has a few limitations. The major one is poor generalization. So, for example, if we train our model for question decomposition only on maths or logical tasks, and while actually asking the question or reviewing, we ask something related to movies or any other field which is not related to the one it was trained upon, then the model might struggle. And the major reason for this is task specific decomposition, as the way we break down a maths problem step by step may differ a lot from the way we break down a movie review problem. The final technique we will discuss is reflection. Unlike previous prompting techniques that focus on improving the current response, reflection focuses on improving future attempts. The idea is inspired by how humans learn from mistakes. So, after completing a task, the model evaluates its own performance, reflects on what went wrong, stores those lessons as memories, and then uses them to improve future attempts. The important thing to note here is that model improves without requiring any additional training or retraining. So these are the three core models for reflection. First is the actor, which actually performs the task of generating a response. Second is the evaluator, which evaluates the response provided by the actor. And third is self-reflection. That is after the evaluation is provided back to the actor. The actor takes feedback from it and stores the important things in memory so it doesn't make a mistake like this in future. This is very similar to how humans learn. So this is the entire pipeline which is followed. So firstly, the actor attempts to solve the question, then the evaluator evaluates the answer. Thirdly, the feedback received from the evaluator, the actor understands its mistakes and stores it in its memory, long-term memory, so it doesn't make a mistake like this in the future. This is very simple, similar to how we as humans learn. So even though this approach works well, like for example, it's actually learning from its mistakes and improving as a whole. And secondly, when complex tasks come, it has been seen that it performs pretty well on multi-step reasoning, coding, and decision-making problems with the help of reflection. But it has a few limitations. First is self-evaluation. The quality by which the model improves depends a lot on the quality of the feedback provided by the evaluator and what the model actually learns from the feedback provided. Secondly, the problem is memory bottleneck. As tasks keep on moving complex and complex, it becomes very difficult for the actor to actually retrieve important information and improve further. So that's going to be it from my side for this video. In this video, we explored three advanced prompting techniques: generated knowledge prompting, least to most, and reflection. Each of these techniques improves language models in different ways via generating additional knowledge, or breaking problems into smaller subproblems, or learning from previous mistakes. If there are any prompting techniques from the literature that you would like me to cover in more detail, including any of the techniques discussed today, make sure to let me know in the comments. As always, if you found this video helpful, make sure to like, comment, and subscribe, and let me know how I can improve further. Thank you guys for watching the video.